Alright, let me show you how to find the derivatives of inverse trig functions. By that, we may take the derivative of something like y equals inverse sine of x. Y equals inverse sine of x is an explicit formula. Y is explicitly written out in terms of x. In order to differentiate it, I'm going to make it an implicit function by moving the sine over to the other side. So we'll have the sine of y is equal to x. Then we can use implicit differentiation in order to find this derivative. So the differential of sine is cosine y dy, and the differential of x is 1 dx. I'll turn that into the derivative by dividing both sides by cosine first to get rid of this cosine, and by dx to get rid of this dx on the right. And we see that what we're left with is dy dx, the derivative, is equal to 1 over the cosine of y, which is great. I have the derivative written in terms of y, but I want to find this derivative in terms of x. In order to do that, I'm going to look back through my process and let the basic understanding of trig help me out. To do that, I'm going to need a right triangle, and I'm going to look back to this very first line of my work where I said that sine of y is equal to x. With a statement like sine of y is equal to x, that gives us a couple pieces of information. First of all, it tells us which variable is the angle. Because I'm finding the sine of y, y must be the angle. And that value is x, like x over 1. Because sine is opposite over hypotenuse, that means the opposite side has a value of x, and the hypotenuse has a value of 1. Real quickly, we can use the Pythagorean Theorem to figure out what the length of this base is. B squared plus x squared would equal 1 squared. B squared would have to be 1 minus x squared, and so b is the square root of that. Which means this side, down at the bottom, is the square root of 1 minus x squared. And that's going to be all I need to rewrite this equation, the derivative of y with respect to x. Instead of being 1 over the cosine of y, looking at my triangle, I actually have a value for the cosine of y. It's going to be adjacent, this square root of 1 minus x squared, over hypotenuse 1, which is just square root of 1 minus x squared. And now we have the derivative with respect to x written in terms of x. Let's try it a couple more times. Here, with y is equal to the inverse cosine of 3x. In order to get started, I'm going to take this explicit equation and turn it into an implicit equation by bringing the cosine over to the other side. So we have the cosine of y is equal to 3x. Now we can use implicit differentiation to find the derivative. The differential of cosine is negative sine y dy, and the differential of 3x is 3 dx. Now, to find the derivative, we will divide both sides by this negative sign to get rid of negative sine y. And I will divide by dx to get rid of this dx. And we see that our derivative, dy dx, is equal to 3 over negative sine of y. In order to find this derivative in terms of x, I'm going to revert back to my very first line of work here and use a right triangle to help me. Since the cosine of y is equal to 3x, that means that y is the angle, and 3x over 1 is the cosine. Cosine being adjacent over hypotenuse. Then to find the missing side, you can use Pythagorean Theorem, which would be the hypotenuse squared minus the other side squared, 3x squared. Great. Now with this triangle, we have everything we need to rewrite our derivative in terms of x. Because we'll have 3 over the negative sine of y, that's the same as negative 3 over the sine of y. And looking back at the triangle I just made, sine is the opposite over the hypotenuse. So the square root of 1 minus 3x squared is 9x squared all over 1. So this will be our derivative. One more. When we have y is equal to arctangent of x squared plus 1, it's important to recognize just notationally arctangent means the inverse tangent of x squared plus 1. But we just continue to follow our steps. Instead of using this explicit equation, we'll make it implicit by bringing the tangent over to the other side. Tangent of y is equal to x squared plus 1. Then we can take the differential of each side. The differential of tangent is secant squared, y dy. And the differential of x squared plus 1 is 2x dx. In order to get it in the right form, I'm going to divide both sides by secant squared to get rid of that secant squared, and by dx to get rid of that one on the right. And what we're left with is the derivative dy dx is equal to 2x over secant squared of y. Now to write the derivative in terms of x, I'm going to go back into my work, looking at this line, and coming up with my triangle. Because the tangent of y is x squared plus 1, that means that y is the angle. And tangent being opposite over adjacent means that x squared plus 1 would be the opposite side, and 1 would be the adjacent side. Real quickly, with the Pythagorean Theorem, the hypotenuse is going to be a squared plus b squared. So 1 squared plus x squared plus 1 squared. Now we have enough to rewrite our derivative in terms of x as 2x over secant squared of y. Going back to my triangle, secant is the reciprocal of cosine, so instead of 1 over the square root, it'll be the square root over 1. So the square root of 1 plus, and if you wanted to, you could FOIL this out. I am cool with letting you leave it like this. However, we should let the square and the square root cancel so that this derivative will be 2x over 1 plus x squared plus 1 squared. If you did want to expand that denominator, you would end up with an answer of 2 over x to the 4th plus 2x squared plus 2. But that would be our derivative.